All right, so now we're on the last stop of the tour of your brain, and we're going to go to the front, basically, front top, frontal lobes. Frontal lobes actually make up half of your brain, and it's actually the newest part of the brain. In fact, when you hear any sort of evolutionary stories about the evolution of man, you will often hear that our ancestors had much more sloped foreheads, whereas let me see if I can. We have a very straight forehead here, and so literally our skull has gone from being here to here, largely to make room for the frontal lobes. And it really is the frontal lobes that we see as really critical for all the complexity that you see in human behavior. It'll also have that distinction that I mentioned earlier, that whereas the other lobes are more about getting information in from the world, the frontal lobes are more about figuring out what to do with all that information and then ultimately deciding what we are going to do and outputting action. So the frontal lobes are more about acting on the world and less about perceiving it. Let's talk about it in detail. All right, so week 2, lecture 7, the frontal lobes. I should have had that up. I should have figured out how to do this earlier. I found some of these, but anyway, I figured it out now. So this is a nice funky little spinning rendition of the frontal lobes. You get a sense of, the size. We're talking a lot of brain tissue here. Let me just let it spin a bit more. And I may have to respin it to make another point. Yeah, okay, so let me stop it here. And as you're starting to get comfortable with some of these landmarks, remember these strips. This was what we called the sensory motor strip over here when we talked about the parietal lobe, and this will be the motor strip here. So it really is the beginning of the motor strip that kind of defines where the frontal lobes start, and then we have this whole curvature that goes around the temporal lobe down here, and so everything to the front of the temporal lobe is frontal. Okay, so let's come back. You've seen this figure before, and I think I already told you, for the most part, that the frontal lobe, it's a very similar, the motor cortex, it's a very similar story as the story we told for this somatosensory cortex, but the major difference being that this is about output. So this cortex in the frontal lobe now controls our body in terms of the actions that we produce. And so once again, we have this asymmetric representation in the sense that the amount of brain tissue devoted to a given body part is proportional to the usefulness of that body part in terms of manipulating the world or acting. So how much we actually move and use that body part. And so you see, I made a big deal out of the elbow. There's not really an elbow on the sensory motor cortex because there's no sensory tissue devoted to it. But there is an elbow here, small, not a lot of tissue. The elbow doesn't do much. It basically bends. But, there's a bit there. But again, the hands, the mouth, the face, the tongue, those areas get a whole lot of cortex devoted to them because we're actually doing very rich, complex movements with both our hands and with our faces. And so, that's all reflected here in this cortical strip. This sort of is the primary cortex when it comes to the frontal lobe, but again, it's more about output, not about input. Now, I want to make a second point that I didn't make previously about the lobes, and that has to do with what's called their contralateral organization. So what that means is the following. The left side of our brain, when it comes to both these sensory and motor strips, the left side of the brain maps onto the right side of the body, and the right side of the brain maps onto the left side of the body. So there's this weird little crossing that goes on. I've never heard a really good story for why we are like that, why we're wired like that, but there's no doubt we are. So if I stimulated, let's say, a part here somewhere that might be associated with your cheek, but I do it on the left side of the brain, what I would see is your right cheek flinch. The muscles in your right cheek would react to stimulation of the cheek motor cortex on the left side of the brain. So there's this weird cross wiring. Again, no explanation. That's just how it is. And it's true of both the sensory, so also the feelings that, the touches. So if I touched for example, right cheek, I would see activation in your left sensory strip. So, yeah, weird contralateral wiring. That'll become relevant when we talk about split brain patients. All right, so if we're talking about frontal lobes now, so we know what that motor strip is doing. It's outputting motor actions. But what's the rest of the frontal lobes doing? Well, one of the ways we know a lot about the frontal lobes is because of these things called frontal lobotomies that you probably heard of. And let me give you a hint of a story about frontal lobotomies. Frontal lobotomies were popular as a psychological treatment before drugs became as prominent as they are today. So there was a time when if you had a patient that was extremely violent, especially, so imagine for a moment that your brother or your sister is well, first of all, has these problems where they can't control their aggression. So they get in fights all the time. They are inappropriately aggressive. They want to hurt people, and so eventually they get committed. And let's say there's no rhyme or reason, so we think, well, this is just sort of some psychological thing. They just can't seem to not be aggressive. Well, what do you do with a patient like that? In the days before drugs, what they did was literally restrain them. They tied them down to beds, tied them down to chairs, and literally these people would be sitting there seething in anger. So imagine visiting your brother in a mental institution, and that's the image you see. Your brother or your sister tied to a chair, angry as heck, and everybody knows that if they let them go from the chair, they're just going to start trying to beat people up. That's a horrible image. Now imagine when you're in this asylum, a doctor comes to you and says, you know what, there's a way, there's something we can do. There's a procedure. It's called a frontal lobotomy. Very easy procedure. We just take this little sort of spatula looking thing, we pass it up usually through the optic. There's a space here sort of by the eye where they can slide it through, or maybe through the nose, but usually through the optic spot here. They'll slide this spatula up and they'll move it side to side. And what they're essentially doing is severing connections from the very front of the lobe to the motor areas, more near the back of the frontal lobe, if that makes sense. What happens? Well, when they originally did this, I don't know why they originally did this. They probably started doing it with animals and doing lesion studies. So there was a time when they would just lesion animals' brains to see what happened. And what they noticed is that when you do this, aggression is significantly reduced. The animals become less aggressive. And when they do it to humans, the same thing. So if this is done to your brother, then the next time you go see him, they don't need the restraining chair. They don't need to tie him up. He will sit comfortably in a normal chair at a table and maybe play cards all day or do something. So in terms of that symptomology, that aggression, that seething anger, that goes away. And you have to, but before we judge people who had their family members go through frontal lobotomies, we have to appreciate how powerful that must have been to them to no longer have that to deal with. But what was left? There's kind of a famous rendition in the movie One Flew Over the Cuckoo's Nest. And if you haven't seen that movie, I'll give you some links to scenes that you can check out. But you might want to check out the whole movie because it's a very interesting movie. Jack Nicklaus here's the star. And it's all about a guy kind of trying to avoid normal hard work jail time by feigning that he's insane, ending up in an insane asylum. And he causes all sorts of trouble in the insane asylum. To the point where at one point near the end they give him a frontal lobotomy because they say, well, he's being aggressive and he's causing trouble and he's blah blah blah, a lot of the story I told you. Now what happens, when he comes back in the movie, they depict him as essentially a zombie. In fact, I don't want to ruin the movie too much, but one of his fellow colleagues actually smothers him to death because he can't bear to see him anymore as a zombie when he was so full of life and full of passion before. There is absolutely that aspect to it. So these are the kind of symptoms that you see of someone who's gone through a frontal lobotomy. And I'm mentioning this not so much to explain frontal lobotomies to you, But I want you to think about these symptoms in terms of this is what the frontal lobe normally does, or at least the opposite of these things. So when someone has a frontal lobotomy, they seem to be very slow in their ability to string thoughts together, and they have no spontaneity to their behavior at all. They seem to want to do the exact same thing one day after another. They never suddenly go, oh, I feel like doing this, or hey, I think I would like to do something different today. That spontaneity is gone. So there's something about the frontal lobes that's related to that in us, our sort of need for new experiences, our need for adventure. And when the frontal lobes are severed, that disappears. That's why we have this stereotype of them sitting there and playing cards all the time, or doing some repetitive behavior. They show what are called perseveration errors, and this is kind of, I think, related to the loss of spontaneity. A perseveration error means that if you're engaged in some behavior that's working for a while, but then suddenly it stops working, what we need to do is understand, hey, that behavior doesn't work anymore, and I need to change. I need to shift in some way. So I need to shift my strategy. Well, people with frontal lobotomies, it just seems like they cannot shift their strategy. You know, as one example, there's something called the Wisconsin card sorting task, where there's these cards that have three qualities to them. They have maybe triangles, squares, or circles depicted in either red, green, or blue. And maybe there's either 1, 2, or 3 of these items on each card. So you could have 3 blue triangles. People are told to sort these cards, and they're not told what they're sorting them on the basis of. So it could be a shape, put all the circles here, all the squares here. It could be color, put all the red things here, all the blue things here, all the yellow things here. Or it could be on number, put things with 1 here, on 2 here, on 3 here. Now the trick of this game is you have people sort for a while, and you tell them when they're doing it right. And so they very quickly learn how to do it right. So maybe it's color, red here, yellow here, blue there. But then at some point you tell them the rules could change. And so if it's you or I, and we suddenly start doing what was working well, but now we're sorting that same way by color, and we're being told, nope, that's the wrong pile now. That's the wrong pile. You or I will sit back and go, okay, something's changed. Let me try something different. And let me see if that works. A frontal patient will continue to sort in the way that used to work. They can't seem to shift their strategy. So that's called perseveration. They persevere, which sounds good, but they're persevering in the face of continual failure. So the frontal lobe seems to allow us to escape habitual behavior when it's not working, or you know, just to shift strategies more generally when a strategy is not working. These patients also they seem to lose their self-awareness. They don't care about what they look like, and that whole sense of themselves as something perceived by other people, they seem to not care about that. In fact, they generally have what we call a flat affect, so they're not happy, they're not sad, they're kind of in the middle. So, you know, that's when I say the aggression is gone. Yeah, they're never aggressive anymore. They're just kind of, right down the middle. And they lose this sense of empathy. Empathy is your ability to kind of feel what someone else is feeling. So if someone else is in pain, you can kind of feel their pain. If they're happy, you can feel their happiness. It doesn't seem like these patients can do that anymore. And so all of this, again, is telling us that the frontal lobes seem really critical for our ability to feel what others are feeling, to respond in an appropriate emotional way, and to have some sense of ourselves. So the frontal lobes seem really important to that. People with lobotomies can't plan very well. They don't seem to be able to think about the future very well. They seem to live in the now, and a lot of yoga people say that's really great to live in the now. It's probably great to visit that way of living every now and then, but also if you want to be effective in the world, you have to be able to plan and strategize. These guys can't do it, so the frontal lobes do that. And finally, they have this weird tendency to confabulate. Now, confabulation is kind of like lying, but weirder than lying. So when you and I lie, we are really trying to deceive in some way to get something. And that's actually, by the way, considered a very high-level cognitive ability, something the frontal lobes are playing a big role in. But with a frontal lobe patient, if you tell them something like, tell me about your brother, and they say, I don't have a brother. And you say, yeah, you do. You have a brother named Phil. Tell me about your brother. They'll kind of go along with it. They'll say, okay, Phil, yeah. Phil's an architect. He's from New Jersey. And so they're doing all this lying, but they're not lying well, and they're not deceiving anybody. They're just kind of playing along. They're producing a story because they've been pushed to do so, but they're really poor at deception of any sort. And yeah, as weird as it sounds, deception is considered a very high level ability. So in order to deceive someone, you have to be able to, you have to know them pretty well, first of all, to know what they're going to fall for and what they're not going to fall for. So you have to kind of have a model of that other person, and then you have to manipulate them via that model. This is all very frontal lobe. And when you get a frontal lobotomy, those abilities are gone. So again, these frontal lobotomies give us a really good picture of the complex things the frontal lobes are doing. A lot of these things have to do with how to appropriately behave now and to get what you want in the future. That seems to be what the frontal lobe is all about. What's the right way to act? And again, it has now that link to motor cortex to actually put its plans into action. That's what the frontal cortex does. All right, so a few links here again. Now that we've gone through the whole brain, you guys are now essentially amateur neuroscientists. Congratulations, you know the brain quite well. But here's another video that kind of ties all those lobes together. Check that out. This is a link to some scenes from One Flew Over the Cuckoo's Nest. In fact, there's a link to the whole movie. I think you can download it for $4 or something if you'd like. And again, another video that kind of goes across the parts of their brain and their function. So this is a good way to just kind of solidify your knowledge through these videos. In the readings, I have something here about frontal lobotomies, the kind of history. There are not a lot of frontal lobotomies performed anymore, so this will describe why they became popular. And then, when drug therapies came in, why we instead started to turn to sort of reversible drug therapies as a way of handling aggression rather than non-reversible frontal lobotomies. Once you get a frontal lobotomy, you don't go back. And finally, this is kind of an interesting thing. It's a psychiatric manual that describes a lot of the frontal lobes and the kinds of deficits you see and basically the functions of the frontal lobes, but it does so in the context of somebody who might be seeing patients literally at their bedside and is interested in whether their frontal lobes are functioning appropriately. So I thought it was a different spin, an interesting different way of interacting with the same material, which is always cool. All right, that's what I have for you for frontal lobes. Now that you kind of know the brain, our last step this week is going to be to tell you about this fascinating experiment, a fascinating situation that happens when you take a single brain and then you sever the corpus callosum, essentially making two brains and to some extent two minds within a single skull. Very cool stuff.